Okay, this is the derivation of our final accelerated motion equation. You will not be asked to replicate this, but I just wanted to show you where this is coming from, as we will not be doing any sort of lab to graph it in class. So please grab page 18 in your packets and follow along with me. So we are going to start with the velocity as a function of time equation, and we're going to solve this for time. So to do that, I'm going to start by subtracting v naught from both sides. And I am not going to substitute delta v for v minus v naught. I am just going to leave it as it is for now. Once I do that, I'm going to divide by a because I want to get delta t by itself. A will cancel on the right side, and I'll be left with v minus v naught over a, which does match this result, so we are happy. Next thing we are going to do is we will take our position as a function of time equation, our x equals 1/2 a t squared plus v naught t plus x naught, and we are just going to replace everywhere where we see a t with our thing we found in the previous step. And then what I am actually going to do is I am also going to subtract x naught on both sides so that I can, as this hint says, get delta x. Right, because I'll be left with x minus x naught equals 1/2 a v minus v naught over a squared plus v naught v minus v naught over a. And so I can essentially, I'll just take out this x minus x naught and substitute it with a delta x. Next step, I am going to take, I do not like having anything in my denominator, so I don't want to deal with any fractions. So I'm going to multiply everything by 2a. So then I'm left with 2a delta x equals 2a times 1/2 a v minus v naught over a squared plus 2a v naught v minus v naught over a. And as you will see, a bunch of stuff will cancel out, right? Our 2a's will cancel out both our a's, right? Because inside this piece, we really had 2a's hiding there since it's squared. My 2 and my 1/2 will cancel out. My a's will cancel out over here. So then I'm left with 2a delta x equals v minus v naught squared plus 2v naught times v minus v naught. I am going to go ahead and expand those things on the right side of my equation. So the left side stays the same. I'm going to expand my binomial here. So that becomes v squared minus 2v v naught plus v naught squared plus 2v naught v minus 2v naught squared. Then we can combine some like terms here, right? Again, that left side stays the same. We see these two will cancel out because that order, v naught or v first, it doesn't really matter. Then I have my v squared, and I have v naught squared minus 2v naught squared, so I'm left with minus v naught squared. And then the last thing I'm going to do, just to make this look how I want it to, is I am going to add my v naught squared to both sides so that I end up with this final equation, v squared equals v naught squared plus 2a delta x, where this v is our final velocity, v naught is our initial velocity, a is acceleration, and delta x is our change in position, or our displacement, which is our x final minus x initial. All right. Thank you for watching this. If you have any questions, go ahead, star that part of this process and ask a question about it later. And I will do my best to help you. I'll see you all in class.